Hi there, 7th graders. Today is Monday, 2 days this week until fall break. All right, our focus is on combined like terms. In your textbooks, this is Chapter 5, Lesson 5. So if you need more additional help, there is examples in your textbook to help you. Okay, the reason why we want to be able to identify and use mathematical properties to simplify algebraic expressions is because eventually you're going to have to get to more complex equations that you would need to find the solution for B. Okay, and so part of that is combining your like terms. And we just learned how to make sure that we can write and evaluate expressions. Okay, evaluate means that they gave you a value for that variable and you plugged it in and then you simplified until you had your remaining solution. Okay, so if you have your composition notebook and you printed out the notes, you'll glue them in on page 23 and 24. Otherwise, do your best to write the problems and then put in your notes with it. Okay, so if you're staying organized and you have this little unit tracker, you're going to fill in that today for page 23, combining like terms, and then on page 24 you have combining like terms 2. Okay, so we got a couple of notes going with this. First thing we want to talk about is modeling. Okay, it's always helped to be able to model so that we can actually understand what's going on. Okay, so to model, we have our x's, positive x, a negative x, positive 1, and a negative 1. Okay, so I'm going to model what this expression of 2x plus 3 plus 4x is. And that will help us know what we have that we can put together. Okay, so I'm going to put 2x's. Woo-wee. Let's go ahead and change that back to normal. I'm going to put 2x's. Okay, and then I have a plus 3. So let's go ahead. Oh, yep, I do have a blue on there. And then 3. So I'm going to put my 1s for my 3. And because there's 3 of them, there's a 3 there. And then again, I have 4 more x's. 1, 2, 3, 4. That's that expression put together. Now, there's nothing I can't cancel out because I don't have any negatives to cancel out my positives. So if you took how many x's you had all together, we have 6 x's. And then we have 3 positive 1s. So that's how we know that we can combine all of our x's together. Okay, now let's go on to number 2. Let's model 5 plus 8x plus 7. Okay, so I have 1, 2, 3, 4, 5. And then for my 8x's, we got 8 of them. 1, 2, 3, 4, 5, 6, 7, and 8. And now it says plus 7 more. All right, 1, 2, 3, 4, 5, 6, 7. So if I was to combine all of my 1s here together, we would have a total of, here's 5. 5 is 10 and 2. So that's a 12 plus, and then how many x's did I have? Just my 8x. All right, so the first 2 kind of easy to model. Everything's positive. There's nothing being canceled out. Okay, so let's start with 3. We have a 5x. So 1, 2, 3, 4, and a 5. But now we have a negative 2. So let's get some red up on there. Okay, now I have negative 1s. I have 2 of those for my negative 2. Okay, if you're subtracting 2, you're taking it away. If I was to rewrite this with adding my opposite, we could rewrite it as our 5x plus our negative 2 plus our negative 3x. That's how I know that I have some negatives I need to put in here. Okay, right now because I'm taking away 3 more x's. 1, 2, 3. With the little negatives. That means I have some 0 pairs. Remember doing that when we're modeling with chips? Okay, we have 0 pairs. So I am going to go through, and for every negative x and positive x, they cancel each other out. Okay, so we have 3 0 pairs that we are able to cancel out. And that's it. So now what do I have left? Well, I have 1, 2. I have only 2 x's left. And then I have a negative 2 1s left. Okay. That's where you can go in and make sure that you understand. Remember our canceling of our zeros. All right, 4, I do not need to rewrite with any adding the opposite because they are all positive numbers. Okay, so we're adding everything and everything's positive. Okay, I have 1, 2, 3 x's. Okay, now I'm going to put 5 1s. 1, 2, 3, 4, 5. And we have 10 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 7 x's. 1, 2, 3, 4, 5, 6, and 7. Now we can put this all together. If I have 3 x's here and I have 7 over here, I have a total of 10 x's. If I have 5 1s and 10 1s together, that makes 15 1s. Okay. All right, 2 more for modeling. We have a negative 2x plus 3. I'm going to add my opposite so I can clearly see that this is a negative 4x plus a negative 9. So now I know what I need to go in and do. Okay, I have a negative x's here. But then I have some positive 3's. So 1, 2, 3. But then here comes the negatives. 4 x's. 1, 2, 3, 4. And negative 9's. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now if we look, I have all negative x's, so I can't cancel anything out. So that's a negative 6x. But with our 1s, we do. I have 3 positive and 9 negative. So for every pair, I can cross them out. So this is how we model it. So if you're asked here in the future to model, that's how you're going to model it. So how many do I have left? I have 1, 2, 3, 4, 5, 6. So plus a negative 6x. Or not 6x, sorry. I read the x and it made me think of that. So a negative 6x plus a negative 6. Okay. Or we could say that we had a negative 6x minus 6. Those mean the same thing. All right. Going on to our last modeling. Okay, so I have 2x plus 7y plus 4x plus 3y plus a negative 5x if we add the opposite. All right, so we got some different numbers and letters going on. You notice we have 2 different variables. So here I have 2 x's, but then I have some y's. Now y's and x's are completely different of each other. And there's 4, 5, 6, 7. Okay, now we have 4 1s. 1, 2, 3, 4, and 3 more y's. 1, 2, 3. But then we got some negative x's to put in. I got to put in 5 of these. Or you count 1, 2, 3, 4, 5. Yes. Now, what we know is all of the middle stuff is positives, but here I have some positive x's. They're going to cancel out 2 of my negative x's. Okay. If I have 7 yo-yos in this pile over here, and I have 3 yo-yos in this pile, altogether I have 10 yo-yos plus my 4 plus my negative 3x. Okay, if you need to, pause that, fill it in. Now let's talk about combining our like terms. Okay, we're going to do a quick 4 short. I would like for you to try to model some of these. If you had 7x's and 9x's, think of them as objects, whether it's $7 here and $9 there. How much do you have altogether? You would have 16x. And then we have just a regular 3. Okay. Same thing over here. I can only really combine those x's. So I have 6 plus a 9x. And then for 3, we have a 4x. And then I normally will circle the sign in front of it because then it makes it look like a negative 8x. And if I was to add the opposite, that's what I would have, is a negative 8x. Okay, so if I had 4 xylophones, but I owe a friend 8, that means I owe them 4 more xylophones. And I have nothing to combine with my subtraction of 4, so it stays the same. That's pretty much how we are setting this all up. Next one, negative 5x. And then here is another, okay? If you borrowed $5 one day and $8 another day, you owe your friend $13. But then, if you have 3 and 12 together, that makes 15. Right? Copy those, and then we're going to go on to the next sheet of notes. All right. An expression is a combination of terms, variables, alrighty. So last week we covered that an expression is a combination of numbers, variables, and at least one operation. Now it can be more than one on both. Okay, so here we have an expression, 2x plus 3y minus 4x plus 10. Okay, we have parts of each expression that we need to put in. Okay, so terms is each individual part. Okay. Okay, so terms are each individual part, and they are normally separated by with having an addition, subtraction, or even sometimes a division sign. Okay, so that's what we would consider a term. So for this one, we have 4 terms. Right? A constant is a number that is on its own. That means there is no variable attached to it. So this 10 here would have been our constant. Okay. So we have 4 terms. We have 10 for a constant. A coefficient is a number used that is to be multiplied. Okay. So we have actually 3 coefficients because those are all being multiplied with the variable. Like terms are the ones that we could combine because they are the same. Like our 4x and our 2x, they are the same, so they could actually be combined together. All right. So if I were to go through each of these and list, hey, what is it going to be? So for our terms, we have 4 terms, our 2, the 3a, the 9a, and the 5a. Constants, any number that does not have anything with it. So that would be our 2. Coefficients, we have a 3, a 9, and a 5. And our like terms are the 3a, the 9a, and the 5a. Okay, so all we're looking for at this part is breaking it down of what goes with what. So for the next one, for number 2, how many terms do we have? 1, 2, 3, 4. Okay, and then go through and write them down. We have a 9, a negative z, a 3, and a negative 2z. And 2's kind of look like z's. Constants, any number that does not have a variable attached with it. So our 9 and our 3. Coefficients, technically what is in front of the z? A negative 1 and a negative 2. In like terms, well, we could put our 9 and 3 together. And we can put our negative z and our negative 2z together. Those are our like terms. Right? I'm going to go ahead and challenge you to do the next 2 on your own and then check your answer. Come back and see what you got. All right, welcome back. So here I filled mine out. Pause it, double check yours to see if you got the same thing as I did. All right, our last section, some little bit of rules that you need to know. To combine like terms, they must be the same variables. Okay, so that's what goes in this space. I'm going to say your variables. Okay, they have to be identical. You can't combine an x with an xy because x times y is not the same as x. Okay, then you must have variables raised to the same power. Okay, so you have to look out for those exponents. X to the first power is not the same as x squared. Numbers by themselves, constants, are always added together. Okay. When identifying like terms, circle the term and the sign in front of it so that you remember if it is a positive or negative. Those are just little tricks to help you so that you stay organized. That's part of what mathematics is just being organized. Integers are a key component here. You must follow all integer rules, okay? And simplify means to combine like terms and reduce all terms. Okay, so if there's a multiplication part, you need to multiply and get everything reduced to its lowest terms. Okay, all right, so finish that up, and then we have a maze that I will start. Oh, wait, nope, I forgot about our guided practice. All right, so we need to identify the terms, like terms, and coefficients and constants. All right, so our terms we know is 5n, a negative 2n, a negative 3, and a positive n. Okay, what are like terms? Well, I can combine, so that was our terms. Our like terms, I can combine my negative 2n, my 5n, and just n by itself. Okay, our coefficients, so that's everything that's in front of these n's. So that'd be my negative 2, a 5, and actually a 1. We don't see the 1, but it is there. It's an invisible 1. In our constant, that is just that negative 3. Okay, so number 2, we're going to write 4p minus 7 plus 6p plus 10 in simplest form. Okay, so let's go ahead and identify our like terms. So I have a 6p and a 4p. Those are only p's in there, so that makes a 10p. And I have a negative 7 and a positive 10 to get a positive 3. All right, number 3, the cost of game G with 7% sales tax can be represented by the expression G plus 7 cents G and then simplify the expression. Then determine the total cost of a game after sales tax if the original cost was $52. So I have two G's here. I can combine those. Like we said, this is like an invisible 1 in front of that G. So if you take 1 and add it to your 7% as a decimal, you get 1 and 7/100. So 1 and 7/100 G. So now we just need to take this G and replace it with the 52. Okay, so if I take my 107 times my $52, what is that going to then equal? Okay, and we get a $55. Remember, your dollar sign goes first, and 64 cents. Okay. All right, our next one. You go to a basketball game and buy 3 waters that cost X dollars each. All right, your brother buys a bottle of water and a bag of peanuts that costs $4.50. Write an expression in simplest forms that represents the total of cost of money spent all together. Okay. So we know, well, how much waters did they actually buy? Okay. So if you bought 3 and then your brother bought another one. So that means we have our 4X plus the $4.50. Okay. All right. Building on our essential questions. Explain why 2X minus a net 2 times the difference of X and 1 plus 3 times the difference of X and 1 equals still our 5 times X minus 1. Well, if I had to draw this out, how many would I have? How many sets of this X minus 1 would we have in total? Okay, so we could say the reason why, if you actually used what we're going to talk about, distributive property, or if you just took and had your X minus 1 and an X minus 1, and you're adding 3 more sets of that, and we combined all of it together, you know you have 5 sets of that X minus 1. All right. All right. So let's go up to our maze. Okay. You're going to start up here. Okay. So this is where we're starting. We're going to combine our like terms. So I have to look. All right. What like terms do I have? The only ones I have is my X and a 2X. Okay. If you have 1 apple on the kitchen table, but 2 apples on the kitchen counter, how many apples do you still have altogether? It's still going to be 3, but then you have to be tricky. So I have a 3X here and I have 3X here, but this is a 4Y. So that's why you need to make sure that you go in the right direction. Okay. So I'm actually going to go ahead. I'm going to go this way. Okay. All right, now let's go and do the next one, and then the remaining you should be able to do yourselves. All right, I have a 5Y, but I have no other Y's, so that stays alone. I have a 2X, no other X's. I can combine, though, my constants of 6 and a -3. Okay, now it doesn't matter. You're going to, because of addition reasons, it can be rewritten in many different forms. You're going to go my 5Y and my 2X. Doesn't matter what order, because that's the commutative property. But my constant should be a 3 now. Okay.